Okay, so you should all have a page called Solving Spheres.
We came to level 68.
No.
It took 12 minutes.
Okay, so they give you two formulas for surface area and volume of the sphere. And they've asked us to find them. You're just plugging into the formula. Yes, you're going to put it in your calculator, but go ahead and show the plugging in part because that's going to matter in a minute. So they did it for the surface area for a basketball with a radius of 6 inches. They did the surface area and found it. Let's go ahead and do the volume. So 4/3 pi 6 cubed.
Inches cubed.
Yes. Everybody get 904.779 inches cubed?
Or 7/8 could we do?
Oh, mine's rounding, so.
And do we have to do that little wavy symbol for the kids?
Technically, yes. What's that little wavy symbol?
About.
Yeah, it means approximately. And that's because we rounded. So, and any time you put pi in and multiplied, you're going to have to do that. Because pi always has to be rounded.
Okay. I was always wondering because I've seen that little sign pop up.
Is that meters cube?
Inches. It's just on the line.
Man, I think you're doing that wrong. That's diameter.
Oh, it is. You're right. Darn it.
Oh my god,
Wrote
I did
in
that
pen.
too. Oh my gosh.
Thank you.
Wait, what?
It's they gave me diameter, and the formula's radius. So I guess we all did it wrong.
Anchor.
Except for Jacob. Thanks, Jacob.
Hey Jacob, are you feeling better?
There's that kid was unstable, well, it's unstable. Okay, now I've had a chance to do proposal, so.
Okay, good. I'm glad. I was worried. I heard that you were. Yeah, she was good. Okay.
But not the first one, right?
No, the first one was fine because they gave us the radius.
So that's like
It's just a
4 point.
Yeah, I was just saying this.
That's mine.
It really is.
Oh man.
Change it 4.6. I was gonna ask you this, Mahan. Are we ever performing it for the?
Not for the student body, but unless we're forced to.
Are you gonna have a day where we can go watch it?
I just got an email from Miss Moore. She's not in town, but as soon as she gets back in town, she's gonna check in and see on a Thursday and Friday night that we'll maybe do it at the middle school. At the auditorium. There you have the stage.
Why don't the high school have a stage or an auditorium or
Because it got lost in the cost
Football
cutting.
field.
yeah?
It was not viewed as important enough. Don't get me
So now we
started.
have to.
Yeah. So now you.
It should be all right. Look, I put inches squared even after all that, and it's not inches, it's centimeters. Darn it.
You really are
Okay. Alright, the cantaloupe, they actually give you radius, so that's good. 4 pi.
Okay, there's stuff like that.
Ugh. And I was like, wow, that was actually pretty good. And then I just hear.
It was great.
Is that?
God dang it.
Gosh darn.
Okay. Are we good?
Sounds good.
Okay, this is what we're doing.
That's how it's.
Okay, so we found the surface area, then we found the volume. Now if you look on number 2, they give us a new function. So the very top of the page, they gave us good old formulas that we've used before that we know about. And now they're giving us a brand new function right here in the middle. V of S equals 0.094 S to the 3/2 power. This function is used to find the volume of a sphere in terms of surface area. So instead of having to know the radius or the diameter, this formula will give us volume if you know the surface area. So this is what we call a composition function. They've taken 2 functions and they've put them together and created one problem for us. So we're going to approximate volume using surface area. So it says use the entries for 2 of the spheres above to verify that it works. So we're going to take V of S, and it says V, they've changed the V of S, so the S is the surface area, V is volume, so right here it was V of S, now it's V of 452.4. So we're going to plug 452.4 into this formula for S. And then you raise it to the 3/2 power just like they did. And notice they gave us the wavy lines because we're approximating. And I get 904.5. Yeah, I got 0.507 or 0.51 is fine. And that would be, we're going to volume. Volume is always cubic. So this would be inches cubed. So now do the same thing for cantaloupe. We are going to find the volume of our cantaloupe in terms of our surface area. So you are going to have to go up to the top and get the surface area of the cantaloupe.
In the end, you end up getting, I guess, the same.
Should be approximately the same thing. It's not going to be exact because we're rounding because of pi. I went ahead and for the volume of the cantaloupe, for the surface area of the cantaloupe, I went ahead and rounded to 1 decimal place. So I'm using 706.9. Which, by the way, the fewer decimal places you round to, the less accurate your actual answer is. So if we went out 6 decimal places, these would be more accurate than if we just round to 1. But in the interest of space, because they gave me a little bit of space there, I'm just going to 1 decimal place. Okay, so my basketball volume, if I compare it, I got 904.507, and up here at the top, when we just found it based on the radius, I got 904.779. So that's pretty close. That's a pretty close approximation. And then on my cantaloupe, I got 1766.71, and this one was 1767.15. So it's pretty close also, yes.
How did you get 1,000, the big number at the bottom?
I plugged into this formula, 0.094, and then I rounded this to 706.9, which is, I got from here, because that's the surface area, raised to the 3/2 power. And I just plugged it in the calculator.
I'm stupid. I thought it was like I thought that was like multiplied by 3.
Oh, it's an exponent. Yes, sir.
Can we get the pre-cal paper that you guys are doing today?
Uh-huh.
We should have that for you.
Okay, so now over here in this box, it says, where exactly is this formula coming from? That's what we want to know. Where did this formula, where'd they get it? So it says, take S equals 4 pi r squared, that's surface area of a sphere, and solve it for r.
Divide both sides by 4 pi.
Divide both sides by 4 pi. That's be the first thing. Go ahead real quick. Solve it for r. Y'all know how to solve. I'll give you a minute. A literal minute. 60 seconds.
I think I got it right.
I think I got it.
Okay.
Is it?
So the word, whenever we see the word solve, it just means get it by itself. So I need r by itself. So I'm going to divide by 4 pi. So now I have s over 4 pi equals r squared. So we can take the square root of that. So I have, now it says to substitute that in to this expression, but before I do that, because we've been working with rational exponents, instead of writing it like that, I'm going to write it with a rational exponent instead. Is everybody okay? So I'm going to write it as r equals s over 4 pi raised to the 1/2 power. Because that's the same thing, right? Everybody okay? Alright, so now I am going to plug that in because it says substitute it into this expression for r. So if r equals all of this, then I can plug it right there in this problem.
How did you get that 1/2?
Wait, how can you break that?
Oh, because remember, it's just another way of writing square root, is raising it to the 1/2 power. Remember your exponent rules, the bottom number goes in the crack. So, or we can reverse that, and whatever's in the crack goes on bottom.
So then could you write it the other way? How with the radical, I just do the 2 right there?
You can, but it's not going to get us where we need to go.
Couldn't you just take the formula they gave you for volume and then solve for r and then just plug that back in? Actually, we have to try to
But wait, if you were going the other way, if you knew the volume and you wanted the surface area, then that's
So
what
now
you
are
would
we
do.
looking for the
But
surface
we know
area?
the surface area, and we're trying to get from surface area to volume. That's what this formula does. This formula finds volume if you know surface area.
I know, I'm just saying, could you do that?
Sure. Sure. Okay, so now that we've done that, I'm going to plug r into that equation. So v equals 4/3 pi times, what was r cubed is now going to be s over 4 pi to the 1/2, and all of that, which was my r, needs to be cubed.
Oh, okay, I need to lower this. 1 second.
Okay, now, I'm going to simplify this because that's messy. So let's simplify. First thing you do when you simplify, please excuse my dear Aunt Sally, is do anything inside the parentheses that you could do. So whenever you have double parentheses, you work from the inside out. I would go inside these parentheses and see if I could simplify anything.
Turn 1/2 into 3/2.
But you can't, we're about to, hold on just a second. But you can't simplify anything inside. So that takes care of please excuse my ignorance, I like parentheses. I tried, couldn't do anything. Next thing is exponents. So let's take care of the exponents here because I have raising a power to a power. So you multiply your exponents and this now becomes 3/2 and that eliminates the need for this bracket. So that would give me 4/3 pi s over 4 pi to the 3/2. Now look, we're trying to figure out where they got this formula
How'd you get 30?
that they were using, or this one up here. Well, we now have s to the 3/2. Our only issue is now we have some 4 pi's and all that stuff. They just calculated those out. They have a decimal in their equation. So obviously they just went ahead and multiplied out the pi's and everything. So you can multiply them out. The calculator.
How did you get
But
3/2?
Yeah.
How did I get what?
3/2.
Because I'm right here raising a power to a power. This was 1/2, and that's 3. 3 times 1/2 is 3/2.
How are you gonna solve if you don't know S?
Oh, we're not going to solve. This is what we call a literal equation. We're just trying to get what they got.
Then what are you putting in your calculator?
4/3 pi
Okay.
times 1 over 4/3 pi.
Over times what?
Times what?
4/3 pi multiplied by
1 over 4/3.
Wouldn't it just be
1 over 4 pi.
Hold on. Hold on.
1/3 p? Or 1/3?
It's made of it.
Did you put 1 in for S?
1/3?
Okay. We need to do one step before we actually simplify, so that you guys can follow. Whenever you have parentheses and an exponent outside of parentheses, that exponent belongs to everything inside the parentheses, yes? Okay, so this 3/2 belongs to the s and to the 4 pi. So I'm going to do that and split it up, just so you can see what it looks like. And the other thing I'm going to do is 4/3 pi, the way that they have it written at the top of the page, they put the pi right next to the fraction bar. That is a perfectly acceptable way of writing it, and you'll see it written that way a lot. But another way of writing it is to put the pi on top. It doesn't ever go on bottom. It either goes next to or on top. So I'm going to write it that way also, just because it makes it clearer about how you're supposed to plug it in.
So 4 pi over 3?
So 4 pi over 3. And then I'm going to put a dot for the times, because I'm getting rid of the parentheses. S to the 3/2 over 4 pi to the 3/2. Is everybody okay? Because that 3/2 goes to both of these pieces. Because they're in the parentheses, so this goes to that and to that. Is everybody all right? Okay, so now I don't know S, but I can multiply all this stuff out to get a decimal and then just put the S back on it. So when you plug it in your calculator,
4 5
it looks kind of funky.
7 3 2.
I should use the other calculator. We use the same one y'all are using. Okay, so
Are we just replacing S with 1?
4 pi over 3 times, since I don't know S, I'm just going to put a 1 there. And that's only because I kind of need a placeholder. Because that 4 pi to the 3/2 is on the bottom. So I needed a placeholder there.
It looks really big.
Okay, so it looks like that.
Okay, but how did you put it in your type? Like,
I just put a 1.
I know. Well,
I put the fraction mark because when I wrote it out,
because when you wrote it out, 1 is by 3 halves. So why
This-
is that?
this has to be downstairs.
Is this what you got?
Yeah.
I don't know what S is. So I can't put you can't put a letter in your calculator. It doesn't know what you're talking about. S is gonna stay S. But I don't know what it is, so I put a 1 there to hold its place.
It's like when I'm trying to put a 1 in that place, and then the 3 halves is like how is the 3 halves your exponent? Okay, that's why
Okay, so then when I hit enter,
4 half.
I got .094,
I didn't get that.
Okay, hold on.
which is what they got. .094.
Dylan, what'd you take?
Miss B, I got that, but I didn't
You didn't plug it in that way? There's probably 6 different ways you can plug it in.
The only difference is
Oh, and that's where you plug it in
I
at.
think
like I swear that was a wait, or no.
That's fine, because the reason why is because 1 is a perfect square and a perfect cube.
That's why you.
And then the reason why you multiply it is.
But whenever I did it, like,
Yes.
Missing?
Yes. Okay, so that's where the formula came from. They took the formula for surface area, solved it for R, and plugged it into volume. So when you know the surface area, you can find the volume.
Can't you?
Yes, I got
Wait,
it.
aren't you supposed to plug it in 1 to the 3 halves? Does it really matter if you put the 3 halves?
No, and I'll tell you why. Should you technically, yes, but 1 is this magical number. 1 is a perfect square, a perfect cube, a perfect fourth root, perfect fifth root, perfect sixth root. It is a perfect root of all kinds. Not only that, 1 squared is 1, 1 cubed is 1, 1 to the fourth is 1, 1 to the fifth is 1,
1 to the 3 halves.
So no matter what you do to 1,
It's 1.
it's 1. So you don't ever have to raise 1 to any power, because it's always 1.
And so you have to write the S and the 3 halves on the end because that's the
Because we took it off, and now we're just going to put it back on. Because we didn't know what it was, so we took it off. Okay, so that's where the formula comes from. Suppose that we have a spherical balloon with a surface area of 325 centimeters when it's deflated. Use this formula, the one that we just derived. That's what it's called when you take something that you already knew, which is formula for surface area of a sphere and volume of a sphere. We know those things, and we used them to come up with something else. That's called deriving something. So we just derived this formula. So it's asking us to use that and this information about surface area and find out the volume of this balloon. So take a minute, find the volume. I got 550.748 centimeters cubed. We good?
Doesn't
Alright.
matter.
What?
Doesn't matter if you round different.
More and more air can be pushed into this balloon until it reaches a volume of 2,000 cubic centimeters. That's a volume they just gave you. So now they want us to take this formula, the one that we derived, V of S, and figure out what the surface area would be if this was the volume.
Put 200 in the B place.
Okay, so we're going to put 2,000 in the V place. Everybody good? Because it's the volume. It tells me that, so that's how I know. If it didn't tell me that, I would know because it's cubed. So I've got 2,000 centimeters cubed equals 0.094 s to the 3 halves. Now, I'm trying to find my surface area. I need to solve for s. So I need to get s by itself. So what should I do first?
Divide by
Divide
the
by
0.094.
Okay, so let's do that.
Oh, wow.
That's not inexpensive. Luckily they are very smooth. Okay, so when I divided,
0.6.
this is where I am now. I got 21,276.596 equals s to the 3 halves power. Everybody good?
Yes.
All right, but I need to know what s is. Not s to the 3 halves power, but s.
So you take the root divide
The
it.
third root?
Easier, easier, easier. Much easier. If I wanted s, just s, that would be s to the what power?
1.
S to the 1 power. So I need 3 halves
Multiply 1/3?
to be to the 1.
So multiply by,
Divide it by, yeah, 1.
Divided by
Ooh, sort of.
Divide it
Close.
by s is.
Let me just ask you a question. I think way back to like, I don't know, 8th grade math. If I had 2/3 x equals, what doesn't even matter, 1. How do you get rid of that 2/3?
multiply by
3.
Halves.
Multiply by,
the denominator.
say, multiply by the reciprocal.
So multiply
Because what happens when you do that?
they cancel out.
Well, they sort of cancel. They become 1, right? Because 2/2 is 1 and 3/3 is 1 and now you have 1 to the x. Okay, so if I want to get rid of the 3 halves power, how do you get rid of it?
multiply by 2/3.
Raise it to the 2/3 power. Because when you raise something to a power, you multiply exponents. So I am going to raise this to the 3 halves power. So, I mean to the 2/3 power, sorry. Now if I raise the right hand side to the 2/3 power, what do you have to do to the left? You have to raise it to the 2/3 power also.
767?
On the right side, your 2's cancel, your 3's cancel. They become 1. And you end up with 767.835 centimeters squared,
You're right.
because this is surface area.
Just not.
Okay, now, what Jacob was saying is right. We could take the square root of the number and then cube it, because that's what this means. But that's multiple steps. We can do this 1 step. Easier, faster, more efficient.
I actually did my.
You did, yeah, it works. It's the exact same thing. This is just more efficient, which is why we use rational exponents, because sometimes they're more efficient. Sometimes they're not, but sometimes they are.
Wait, how did you get 767?
I raised 21,276.596 to the 2/3 power. I raised it to the 2/3 power.
So all you did was the little arrow up and 2/3.
Yep.
Okay.
Okay. So, can this equation be solved algebraically? Of course it can. We did that already. I'm not going to write this out. We did it on the other page. But I am going to tell you what the steps are. You are going to isolate the variable and the exponent. That's what you do in that first step. We divided by 0.094, which is how we isolated the variable of the exponent. And then we raised both sides to a reciprocal. I'm going to call it a power, but that's fine. Exponent, same thing. Essentially. So you're going to raise both sides to a reciprocal power. These are the steps you follow every time to solve one of these. So for A, we need to first isolate the variable and the exponent. So how do I isolate them on A?
Subtract 11.
Right. So I have A to the 1/3 equals 5. Now I need to get A by itself, and so step 2 says, raise both sides to a reciprocal power. What's the reciprocal of?
3.
30.
Yeah.
I like this.
And there's an answer bank, so you can see if you're right. There's my answer. Oh, nice pop that one. I think that's what they want us to do. Okay, so on B, you have to first isolate the variable and its exponent. So I'm going to add 184. Now on this one, yes, could you just take the 5th root? Of course you can. Or you can raise this to the reciprocal power. What's the reciprocal of 5? 1/5.
Answer 3.
Okay, C now. I've got a little more isolating to do this time because my variable has more things with it. What do I get rid of first and how?
The 11.
Good. How do you get rid of it?
11.
Multiply both sides by 11.
Would you have to just, no, okay. Do you have to?
So then I subtracted 4 from both sides, and I got C cubed equals 216. I actually can do this one in my head, but you could raise it to the reciprocal power.
Oh wait, is it 8? 6.
Okay, on D, first step, to isolate the variable and the power. So I'm going to divide both sides by 16. So now I have D to the 1/4 is 2.5. You're going to raise it to the reciprocal power. Everybody good?
Here, wait.
Okay, on E, again, you've got a few more things to do in order to isolate it. So the first thing you have to do is add 35. Then I'm going to raise it to the 2/3 power. Isn't this easy? Don't forget how to do it. No, this is it. But you'll forget how to do it. When the test comes, y'all will be like, we've never done this before. And I'll have to get this worksheet out. Do y'all remember this worksheet? We said it was so easy. We popped balloons. You remember that?
We had a good time.
Oh, we had so much fun together popping balloons. Raise it to the 3/4 power. G, and I moved the 68 over. I'm gonna go ahead and rewrite that R. Instead of the 1.5 power, I'm gonna rewrite it as the 3/2 power. That way I can easily raise it to the reciprocal. You don't have to do that, by the way. You could just leave it as the 1/2, and when you raise it to the reciprocal power, you can raise it to the 1 over 1.5. That works too, since we're using a calculator.
I did something wrong.
How do you know? Because your answer's not there?
Yeah.
Oh gosh, mine's like 8,000 or 8.
Mine's 77 point.
Okay, mine's 49, so let's see where you went wrong. Okay, so the first thing you do is you add 68.5 and you get 171.5? Yes?
Oh, it's supposed to be,
And then you divide by, 49's right. And then you divide by 0.5.
Hold up.
supposed to be 2/3.
And then I raise it to the 2/3 power.
Okay, yeah, it's 49.
Yep.
Yeah, I did it right.
Okay.
Ooh, I didn't do H right.
Oh
I
gosh,
got 4,
I
6,
did
7,
not.
3, 7, 3, 2, 7,
I got
4, 9.
32.
1.5 is 18 pounds.
I think I didn't do the 1/8 right, because I just divided it by 1/8.
Oh, don't divide. How do you get rid of an 8 that's on bottom?
Multiply by 8.
Yeah, we're going to multiply both sides by 8.
4,000 minus.
4,000.
Okay, so now here's one now. I do, off the top of my head, know what that is as a fraction. But what if you didn't?
12.
That's okay.
4 over 10.
Still raise it to the 1/2, to the reciprocal power. When you raise it, I'm going to raise it to the 1 over 2.4. Because that would still cancel the 2.4, right? So if I do that, I can raise this to the 1 over 2.4.
What's the fraction?
12 fifths.
It's 12 fifths and then it's like 12.
Oh, 32. Love.
Duh.
30.
So easy? Are we good?
Yes.
All right.
Love it.
Yay.
We have homework?
Don't forget what you do. Don't forget how to do it, though.